this just because I'm using the free version.
Okay.
So no, not to record it, just in general. A 40-minute limit. So let's try moving on. Okay, this is for 8 math marks. I'm pretty sure I've seen this before. I just don't know if I ever saved anything.
Yes, I will also look into it.
Okay, I've seen this.
Okay.
Okay.
How do they do? Yes.
How do they do it? Let me find my notes on this. Yeah. So we know that let me open up Word.
Okay.
Hope this won't take so long if I type it out, but it's better if I type it out because when I do it by hand, it's messy.
Okay.
Insert equation. So we know that Newton's method we have. Let's try this. Insert.
You think she's gonna pick up questions from the previous papers though?
I don't know because all the papers I've seen are very different.
Yeah, but I've seen more similar ones, like question 3, 2017 June and 2011 June. They are more
Similar?
Yes, they are very similar. I've also picked up question 4, 2015 November. Question 5 is similar to what was that? Yes, 2015 June was similar to 2016 10.
Mm-hmm.
So I just can't figure the pattern of these questions though.
Me neither. I know there's always a question on gouge and stuff.
Yeah. But what I'm sure of is, yes, the Gauss-Seidel iteration. I'm sure there's gonna be something on it.
Mm-hmm.
Even the I think LU decomposition.
Mm-hmm.
Yeah, I've seen most papers having it.
What's it? LU decomposition. So we need to learn those two, right?
Yeah. Well, I think because I've seen most papers having those two, the Gauss-Seidel iteration and the LU decomposition.
Okay, so okay, this is taking too long. Okay, M+1. So we'll skip to those questions next. So just do this one because I have the answer. But I'm just typing it out to make it easier.
All right.
Xn equals.
Okay.
Equals xn minus.
Is minus xn. Yeah, I see the equation.
Minus
Xn. Is it minus 1? Minus 1.
xn squared.
Yeah. What's that again?
gosh, it's taking forever. But maybe like as time goes on, I'll be better at this. I'm just getting the hang of everything now. Xn squared minus n, and being the number, divided by 2. Xn.
Okay.
So I'm saving this because in case I'm going to copy and paste it.
Okay.
So this becomes, let's say they ask us to find square root of 7.
Yeah.
Can you see root sign somewhere?
Root sign. Yes. Yeah, there.
7. You're going to have more of this annoying stuff. Okay. X1.
Okay.
You make basically you make X1 equals X0 minus X0 squared minus 7.
Okay.
It's not letting me. Okay, it doesn't really look like minus 7. It's really, they made that 7 a subscript, but we don't really care because we're in a rush. Yeah. Minus 2x0. So if they usually tell you what was x initially?
It says let k be given a number. K is greater than 0, right?
Mm-hmm.
Applying Newton's method to compute the root of k, i.e. derive the approximate or appropriate algorithm.
So they tell you, but they're probably not asking for 7, they're asking for k.
For k, yes.
Instead, but if we told that x naught equal, we asked to find that at x naught equals 3, we would do it like this. X1 equals 3 minus 3 squared. You see, I've given up on being fancy. Minus 7 over
2 times 3.
That's how you do it if you ask to find the root of 7. But how to find the root of k, you get an answer for this. And you might, if it tell you for 2 iterations, 3 iterations, you do it.
Okay.
But I don't know how to do it out of k. That's my issue.
Yeah.
I think they're asking for an algorithm over here.
Yes.
So it would be in pseudocode?
Maybe.
Okay, it's not here. Okay, fine. Should we move on?
Yes, we can move on.
Okay, fine. So to calculate the square root of 5. Oh, yeah. If we just do the square root of 5, we do it like this. Square root of 5. X1 equals. This is how we do it for find the square root of 5.
Okay. And then that's 1.
Then we do 2. We take that answer. Which one?
And then we substitute. Okay.
And then you do x2 equals x1.
X2. Oh, yes.
So you keep on doing that. Okay, fine. So is it diagonally dominant? Diagonally dominant means? Okay.
Is the main diagonal is great. I think I've seen a question like this.
Yeah, I've seen this one. So basically, Okay, basically A11, which is 8, is less than 4 plus 2.
Yes.
A22 is bigger than 0.
And 0 is?
Because we minus 2 plus minus 2.
Yeah.
Bigger than minus 2 plus 2. And A33 is smaller than 7 plus 2.
Yeah.
I'm trying to remember. It's diagonally dominant. It can't be. It can't be because in order for it to be diagonally dominant, it means that that middle outline is bigger than everything else in its line.
Yes. So what I've seen is, I think it was 2016, June, question 2. We had a matrix with fractions. So what they said is the modulus of A11, which was a 1 over 4, they compared it with A12 plus A13. And then what we found out is A12 plus A13 was greater than the A11. So it was concluded that A is not diagonally dominant.
In order to be diagonally dominant, it has to be bigger than everything else or smaller than everything else?
It has to be, I think it has to be bigger. Actually, it has to be bigger. Meaning that the 8 above here, the 8 at A11, has to be greater than the sum of 2 and 4, or either is of either 2 and 4, and then minus 2 and 7. So the 8 should be greater so that it's diagonally dominant.
It should be bigger than 2 and 4?
Yes, the sum of 2 and 4, and yeah.
So no, it's not diagonally dominant because A22 and A33
no,
are
it's
off.
it's actually diagonally dominant.
Wow.
Because 8.
But that's only the first row. What about the other 2 rows?
I'm not really sure how they did this.
Okay. No, it's not diagonally dominant.
It's not.
Because you can see over here, only in the first row is this 8, 3, and minus 10 bigger than everything else in its row.
Yeah. Are both less than? Okay.
Okay.
All right. I see.
Use the gas.
So we check for each row. Oh,
the A11, A22, A33, the diagonal.
And A33. Okay. All right. Oh yeah. Okay. Use the Gauss-Seidel iteration method to find the solution to the linear system. This I didn't get.
Gauss-Seidel method is?
Actually, I never actually got the solution to this. But yeah.
I'm just going to copy and paste the formula but I guess for the exam we'd have to memorize this.
Okay.
I mean, I have it over here, but it takes forever to type out, so I'm not going to waste our time on that.
Where are you situated?
Overseas, but the same time zone as South Africa.
Oh, okay.
they give you this. Trying to find the one that allows us to copy and paste. Because I'm not in the mood of typing everything out.
I just wish she had given something, more
Did you
precise.
see it in the other exam? I don't remember which one it was.
You know what?
Other papers, other things had a scope. Look here. That in the past paper for 2013, it says chapter 1, we don't have to do, you may omit section 1.4. Chapter 2, study everything. You should be able to give a brief description of each of the iterative methods as discussed in this chapter and note their differences.
Okay.
Chapter 3, you may omit section 3.7. You should be able to differentiate between divide differences and forward differences and how they're used to obtain interpolating polynomials.
Okay.
Also, should be able to describe the construction of the computer Rubik splines.
Oh, okay.
Chapter 4, study everything. You should be able to use both closed and open Newton-Cotes methods as well as the quadrature methods to approximate an integral.
Okay.
Chapter 6, you may omit 6.7. You should be able to describe special matrices and why they're important in solving linear systems.
Okay.
Chapter 7.1, 7.3, and 7.5, you should be able to describe iterative methods in matrix algebra and be able to use them to solve simple linear systems.
Okay.
Chapter 8.1, you should be able to describe such a least squares approximation, line parable explanation for a given data.
All right.
This is from 2013. I don't know how much has changed since, but it's pretty much.
Yeah. I get you.
Okay, then. Gosh, I have to learn so much. I'm trying to find a tapped out version of this because just do it this way. Gosh, I need to study so much and like working. Yeah, so this is the formula. So we use the Gauss-Seidel method.
Yes.
So we're gonna have this is correct. Know what might have it? Oh, the summary document. Like this way would help us. We can just learn this. You know what I mean?
Uh-huh.
Okay. Anyway, so let's just do this. XR equals BR minus the sum of JJX, the JXR minus ARJ minus over X over ARR. Okay.
Oh, I see.
So gosh, okay, let's get this party started.
Oh, I see. It's the weird equation we've had. I think I've seen this equation. Let me just find out where the paper is. Maybe if okay, you have the 2016 May-June memo.
Do you have it?
Yes, I do have it.
Can you share it with me?
Okay, how do I go about it?
Send it to me in Telegram. You can share it to me here or on Telegram.
Thing is, I'm now connected to my PC, but let me see what I can do.
You can send it to me on Zoom.
I can. How do I do it? Let me just press share.
No, that will share your screen.
Yeah, it's only gonna share the screen.
Maybe you wanted to send me the memo on Telegram. Oh, I've got Telegram on my computer, by the way.
How do I
I
have it on
downloaded
my?
it.
Oh, okay. You can give me your email. Just quick.
Is it easier than you? Okay. You send it to my UNISA email?
It's okay. I'll just use my Gmail.
So 59.
Okay, let me just.
Or you can share your screen. Do you want to open it up on your screen and show it to me?
Did you download what's this? The folders from the drive?
Not all of them. I'll just open it
Okay.
here. I'm going to open it here. I'm going to open it on my computer.
Okay.
Okay. Where is it? 2016?
Yes. You see, there's no, not there. Go back. You see, here, COS2633 past papers, past examinations. I think here that's where you can get everything.
Yeah, May, June 2016 memo.
Yes. Go down.
Oh, yeah. You would write this
Yes.
down. This is what we did before, right?
Yes. So go down. I think I've seen the.
In that video, we did a question like this, by the way.
Oh, okay.
Okay. Oh gosh, I wish I would have printed this.
Go down.
Yeah.
Yes, there. Yes, that's the equation. Thing is now they were solving a 3x3 matrix. So right now what we have is a 2x2.
I'm just stressing for this exam.
Same here.
May, June 2016 memo. Okay, it's not working. Okay, fine. So what do they do? Oh, here it is. May, June 2016 memo. Doesn't work. Okay, fine.
Yeah.
Let's just look at this. So, oh God, I'm gonna do it by hand, and then I guess both of us do it by hand. And I don't have Telegram on my phone, so.
Okay.
So that's why it'll be easier, because then I'll be able to send you pictures on my paper. Unless you do it by hand, and then you could send me pictures.
Right. Thing is, okay, let's just try it. The thing is, I didn't understand whether he had the different iterations, the first, second, and third. Yes.
What do you mean?
Because now, when you look at the first iteration, where we have 1 over 10 x2 to power n. It goes on, and then on the second one, we have n plus 1, and then it goes back to n. And then on the third row, we have n plus 1 and n plus 1. I didn't quite...
This is in this thing. Huh?
Yes. We either have the first iterations.
Why is this 1 over 4?
Oh, it's 1 over 4 because look at the main equation.
Okay, I was looking at the wrong thing.
Yes.
Okay, it's 1 over 4.
It's 1 over 4.
Okay, which is 4.
Yes.
9 over 10 minus 1 over 10 plus 7 over 20.
Uh-huh.
1 over 10.
Yes. The 1 over 10 is... The 1 over 10 is A12.
Oh, is it 9 out of 10?
It's 1 over 10, right?
10 coming from?
9 over 10 is actually the answer, which is your 2 by 1 matrix. The answer of, look at the main matrix.
I guess the first one is...
Yes, where you have your A matrix and your B matrix. Yes, right there.
Oh, it's here. Okay, it's the first
yes.
B. So it's 9 out of 10 minus 1 over 10 x2, x1, minus 7 over 20 x2. And then you do it for all of them.
For all of them, yes. So what you do is just iterate by using the equation, the main equation, which we're given there.
Mm-hmm.
Yes.
So here is let's try it over here. We see over here that it also is, we have this X and Y column separate, right?
Yeah.
So it's really, gosh. Basically, ideally, that first column would be X's and the second column would be Y's.
It would be Y's, yes.
So it'll be like 4x minus 1y equals 2. And the next one will be 1. Am I taking that correctly? X plus 3y equals... Is it X and Y telling me that if it isn't X and Y, that vector, it'll be X1, X2, X3, X4 going down, correct?
Yes, correct.
How do you see that?
This is so confusing though. Shit.
Okay, I'm trying to understand what this X and Y are doing. That's what I want to know.
On the 2017.
Yeah, is it 4x minus y equals 2?
Is
that what it's saying? I'm trying to understand, do these X and Y correspond to the X to this one and the Y to that one? Or does X this whole row and Y that whole row?
No, they both correspond, because what you're gonna do for you to get a 2, you have to multiply your 4 with the X and minus 1 with your Y to get a 2.
That's what I thought so. Okay, fine. We're good.
Yeah.
Okay, fine. So I was just clarifying that. So I placed it all together. Now I'm gonna try do this Gauss-Seidel method. So I'm doing the first version, row 1.
Okay.
Trying to see if I get a good format. For X, 1 n plus 1 equals 1 over 4.
2, which will be 2
2 minus You're right. What are we going to do if it's 2 by 2 matrix?
Yeah. It will be, what will that be? Your minus.
Yeah, I think they left it out. They don't include it. They don't include x1 if it's used in the first instance.
Yeah.
Right? They just times it in. Equals 2 minus y. Minus 1.
Yes.
1y. So it equals 1/4, 2 plus y. And then we have x2 equals 1. 0 minus 3y, which equals minus 3y. So top row is minus a half minus y over 4. No, minus.
Okay.
The first one is a half minus y over 4. What did you get? Is that the same thing we got together?
Yeah, something like that. Because it's gonna, your 1/4 is out of the whole thing, right? So it's gonna be a
Look,
half
you're going to
minus.
times that in.
Yeah. So it's gonna be y over 4, right?
It's a half minus y over 4.
Yes.
And equals 3y. We're doing x1, x2, x3 still, or are we doing x, y equals?
Oh, this is so confusing, eh?
Let's Google this. Gauss Seidel on 2 by 2 matrix. It's Gauss Jordan. Where is? Nope, too easy.
Okay.
What should we do? Should we move on?
Yeah, we should. I think is I'll try find solutions to this, and then I'll try send to you before the end of
I found perfect. Next thing. Next question.
Yeah,
well, at least we know the Gauss Seidel method, even though we don't know how to do it in this case, but we do know it. Okay.
Yeah.
The matrix has an LU distribution. Use the distribution to find the linear system.
Oh yes.
I didn't study this at all. Like
So
I didn't get around to this equation, this section.
Okay. So what happens is, you know the LU decomposition, right?
Yeah, I've heard of it. But I always got caught up in what is L because I can never find out what L was.
Okay. I think it's when you have the lower triangle of your matrix.
Yeah, but how did you find L?
You see when you're reducing your matrix, when you're actually finding an inverse of it. And then your coefficients, you can actually Google that, YouTube that.
Yeah, and found it.
They will explain clearly.
Exactly. I do have notes in them. Let me look. See if I can find it quickly. Otherwise, moving on.
Yeah.
So you know how to do that?
Yeah, but I've seen it once. I still have to practice it. Yeah.
So, should we do it now quickly together?
we can actually, because we have matrix A. We can find the
so they did that how that's what she was saying, is because the exams were limited, they won't ask you to find everything. It just takes too long.
Okay. Thing is, we have A. We can find the we can reduce A to by Gaussian elimination, right?
Yeah.
Where we find yes, our main diagonal as ones.
How you do LU decomposition? Let me see if I can find something quick on LU decomposition. LU decomposition.
So what we do is
I don't want to video because videos take longer. Let me just get a quick like reminder, you know, because I've done it before. I just forgot.
okay.
Just helping you. It's 1 over LR, or the first thing, matrix BR minus LR 1J.
Okay, but first you need to find your L matrix and your U matrix.
The thing is, they already found it for us, right?
Oh yeah, yes.
They told it to us. So the first thing is 1 over LRR times B minus LRJ.
Uh-huh.
So we're going to have 1 over 1. Where does the U coming?
Where is trying to go through everything I did.
Here it is.
Okay.
We're going to prove that this becomes this, right?
Yeah.
Then comparing the right and left hand sides, row by row, implies that U11 equals 3. U12 equals... Oh, this is what you're going to be doing. U11 You find anything similar?
No, I'm trying to check everything I have here.
Go ahead.
I can't find where I solved this. But what I've been doing is I've been checking the memos and then trying to actually
Match them up.
use them as the guide. Oh, here.
You found it?
Yes, what they said is we know AX equals B, so we have to find let y equals ux. So what we know is we know AX, A small x equals B. Therefore, it's L U small x equals B. And then we let our y equals to ux, and then we solve for ly equals b to find y, then ux equals y to find x. Yeah, that's.
Can I understand how they get from here to here? Understand they told ly equals b and ux equals y.
Yes. So
how do they get this?
Let's see with our LU here. So our L is a matrix with both one as a main diagonal, right? So that's our L, and then we equate. We say Ly equals B. So what we can do is equate. Wow. Yeah, we can equate L, which is 1 over 3 and 0, 1. We can multiply that with y1 and y2 to get our b, which is yes, which is
this is video on it. Let's see.
Which is 2 and 0, right? So we can solve.
Should we watch a video on this?
Yes, we can.
I mean, did you work it out?
I'm trying to work it out now.
So do you want, you can like mute it and I'll watch this meanwhile.
Okay.
Up to you. I mean, yeah, I don't want to disturb you working.
No, it's okay. You can let it roll and then I'll just solve this. think I have
You
it.
have it?
Yes.
Let me just flash watch this video.
Okay. So we have to find to find the solution to the linear system. So we have to find x and y. Wow.
Is that it? That's how you worked it out?
So what I did is I found x1 and x2 and y1 and y2.
Okay, fine. So using that formula, did you substitute your answers that you got for y into ux equals y?
Yes.
What did you get?
For my y1, y1 I got a 2. Y2 I got 2/3. My x1 is -6/11. My x2 is 6/33.
What's your y1?
Y1 is 2.
And y2 is?
2/3.
And then you substitute those answers in to make ux equals?
Yes, I did.
Okay, great. So I'm going to try it. Do you want to wait for me and maybe go on to the next question?
Yes, I can wait for you.
Go on to the next question, maybe.
Oh, that one is the one I was actually working on now. So we'll do it together. Question 3. We'll just do it together. I'll just wait for you.
How about it won't be long? Should we time myself? We need 5 minutes. Hopefully I'll be done then.
Okay.
Sorry, I just wanted to make sure I understood it for my own future reference. Yeah, 1 minus 1 over 1. What did you say was your B?
My B, I used 2. Oh shit! You know what I did?
What happened?
Oh, I used a B, which is a 2 and a 0, while I was supposed to use a 4 and a 5.
Where'd you get it from?
Let's see. Let's look at C. What I did. I was supposed to use a 4 and a 5.
Can't you do it together then?
What I used was the previous one of COS2633.
Oh, ouch.
Yes. So let me just do it quick. It'll be. My y1 will be a 4 though.
What 1 was 4 and y2 was -15? Did you get that?
Sorry?
I got
y1 is
equals 4 and y2 -15.
y1 is 4, right? Okay, 5. I have a 19/3 as my y2.
Okay, how did you get that?
Because
Well, I got for fans 15 was goes -1/3 y1 plus y2
yes.
equals 5.
Yes.
So you put -1/3. Oh, you're right. I was wrong.
Okay.
So I make it plus 1 over 3.
When it crosses to the other side, yes, it becomes a 4 over 3, right? So it's going to be y2 equals to 5 plus 4 over 3, which is 19 over 3.
5 over 5. I'm just doing this maths. 5 minus 1 over 3. Actually, plus 1 over 3. Equals 16 over 3.
Is it not 19?
I've got 16 over 3.
Okay. What you do is...
That's wrong. What I was doing was, I did minus 1 and 1. Y1 equals,
yes.
5. Equals 5. So I move this minus 1 over 3 over to 5 plus 1 over 3.
But you have your y1, which is a 4. Your y1 is a 4.
Oh, you times it in first?
Yes, you can multiply that first. And then solve for y2.
Okay, probably makes it. Yeah, I got 19 over 3 now. Sorry, thanks for teaching me.
All right.
Practice. Okay, I've got 19 over 3, so we're going to try and make this into with the UX method. 132 over 3. 19 over 3 4 equals. Are you allowed to solve the bottom first?
Well, in this case, let's see, x2 is equal to 19 over 3 divided by 11 over 3. Are you using a scientific calculator?
I should be. I like doing everything by hand, but I really should be using it because I make mistakes.
Yes, I think that will make things easier for you. Because I got my x2 as 19 over 11.
And you started back into the first row, right?
Yeah. And then
And you do 4 minus 19 over 11.
2, 19 over 11 equals 5.
Equals 25 over 33 and 19 over 11.
I'm working on it now. I got a minus 17 over 33.
For what?
As my x1.
25 over 33.
So x1 is minus 17 over 33. My x2 is 19 over 11.
I know what I'm doing wrong. I've got 12 11 now. What am I doing wrong? 20 minutes online calculator to see what happened. I did for x1, I did 4 minus 2 times 19 over 11 divided by 3.
Okay.
And I got 2 over 11. What am I doing wrong? Let's use the online calculator to see.
Okay.
What did you get for that? You got what?
My x1 is minus 17 over 33.
Yeah.
My x2 is 19 over 11. My y1 is 4. My y2 is 19 over 3.
So I got my x1 to be 19, to be 2 over 11.
To be?
2 over 11.
Okay. How did you get it?
For 25 over 33.
Okay. Your x1.
What?
You saying your x1 is?
The x1. What am I doing wrong? I got 2 out of 11. Something is totally wrong with me. I don't know what to do now. Do you want to show me what you're working at? Why am I getting this wrong?
I have a really, really rough sketch with me. Let me just send you what I have on Telegram.
Fine.
Yes. It's really, really rough. So, okay, let me just guide you towards it. Okay, I did send.
No, perfect. I don't want to do now. So we just have to still move on, I guess. Okay, your answer was?
X1 is minus 17 over 33.
Yeah. How did you get that? What did you times? Yeah.
What I did, okay, it's sent, yes. Yes. So we both got 4 and 5, right? 4 and 19 over 3.
Mm-hmm. Let's see how they rotate it. I think we got different answers for the first thing.
Okay.
y2, correct?
Yes, we got the same thing for y1 and y2, right? Which is a 5 and 19 over 3.
I got 14 and 19 over 3.
14, not a 4.
I got a 4, sorry, 4 and 19 over 3.
Yes, it's a 4 and a 19 over 3, right?
You got.
Oh shit. No, it's me. My bad. It's me. Instead of a 4, I had a 5 here, so it kind of messed.
What you get then? Do you get 2 over 11?
Let me just work it out. So it's a 4 there. So it's a 4. You're probably right. You got a minus 2 over 11.
I just got 2 over 11. I don't know. I got 4 minus 2. 2 times 19 over 11 divided by 3.
So what I did was on the second one, when calculating my x's, I have minus 3 times x1 equals 4, right? It's minus 3 plus 2x2 equals 4.
Minus 3.
x1 plus 2x2.
Maybe that's my problem. Let me see. Yeah, I don't think I had a minus.
Yeah, you still have your minus x.
Oh, I did. I left out the minus. That's really the problem.
Oh, okay.
So minus 3. Okay.
X1 is plus 2x2 equals 4.
So minus 2 over 3 then.
Yeah, equals 4, right?
Yeah. Why is it the rec method? Right? The answer this method better than direct method matrix.
Wow.
Do you see any memos that claim question?
Nope.
I think I've seen it before.
I've never seen it before either.
It's more of a theory kind of question.
Yeah. So we can just straight up jump to question 3.
Yes, we can see if we asked before. Yeah. Journals give exact solutions are more suitable for small scale systems, but iterative methods give approximate solutions are more suitable for
okay.
fine. So that's what I see. If you want, it's better to use a direct method if you want an exact solution, but if the system's too big, you should use an iterative method.
Okay. All right, cool.
Next question.
Yes, question 3.
F minus 2 is used to Lagrange motivation function.
This was before we started this conference. I was actually working on it. So what they say on YouTube is like now.
Yeah, let me just that video I sent you.
Sorry?
Someone asked for the video I sent you.
Oh, okay. Oh, I should probably send the link so that I download it, because I don't have Telegram on my.
Question 3.
Yes.
Use the engaged explanation formula to. Oh, this is all for what? Have you seen this question before?
That one, I was actually going through it. So what they do is with the Lagrange approximations, we have the polynomials. So in this one, I was doing a trial and error kind of thing. Let me just send you what I have so that you see what I was trying to do.
Together, you know what I mean?
Yeah.
I'm very happy we did a police composition because, like, you know, when we see it, it's going to come up, you know what I'm saying?
Yes, true. Yes, I just sent it now.
Oh, I forgot how I did that. Yeah, you're right. So you're just going through it?
We can, because the first second order method I used gave me a -15, but I kind of thought it's wrong because they said our answer should be in some decimals.
Calculator never could have rounded something off somewhere along the way.
So that's when I was using the third order, because I got a -15, and then I was trying to do the third order. Which is just below the -50. Yes, where I have my three brackets on each.
What an Artemis exam is going to be, it's going to be many small questions on everything. The reason they'll ask us this because it's so long. I think she wants to answer the question on every single page for like the small question.
Okay. Yeah, but with this one, I think if we do the correct thing, it's not that much. It's just once we've done this, once we've identified this, it's just a plug and play, and then we can find how much our fx is at 0. Yes. Just like I was doing right here. So I just had to like substitute all the values for my x's and 0 so that I find what is the value of fx at 0.
But based on her conversation with me, it seems like she's not going to be asking this long question because it'll take too much time for us.
Okay.
So we should skip it for now because it takes too long.
All right.
You know what I'm saying?
Okay.
Based on her conversation with me, it looks like she's going to ask absolutely everything. This topic is absolutely everything. A question, 5 questions in each chapter, but they will all be small questions, but they need advanced knowledge.
Okay.
Why should the grade formula be used only, practice only in portion? She's going to be focusing a lot on methods, so like the theory behind it, and actually close to the actual. Doesn't give us anything. Let me look if my notes give me anything.
Okay, so where can I find the notes you sent?
Which notes? I shared it on the group.
Okay. When did you send?
Okay, on Friday.
Let me check. Can you directly forward me?
Yeah, I'm doing it now.
Okay. All right, thank you.
I got my note. On the summary note, it tells you the disadvantages. The degree of permeability to be used is not known. If the degrees too low, the estimates are not very good. And if the degrees too high, and desired oscillation in the polynomials of values appear. Desire to add or subtract a point from the set used to construct point, and we'll have to start with the computation all over again.
Okay.
Basically, I think we never know how much degrees to use it. If we choose too low degrees, then the estimate is not very good. If we use too high, then we have too much oscillation with the higher variable. And if I want to use trial error, like maybe add and subtract, like, you know, I use 2 points here, it's too low, and we try 3 points, but it's not all over again because you're timesing over here.
Okay.
So it's not, you know, it shouldn't be the best thing to use because it's just like so tedious because you never know exactly. Trial error, because you use trial error, you have to restart every time.
Okay.
What's the error is x minus x1, x minus x2, x minus 3, x minus x1. The f, I don't know what this says. F epsilon over n plus 1. You know what I'm talking about?
Thing is, I can't see what.
Yeah. What does this say?
Oh yeah, the error. Okay, yes.
What does that E stand for?
The E?
Yeah.
I think it's the error.
So they would tell us what the error is?
Do they?
Not that E, that epsilon, that funny Greek mark. What does that mean?
Yeah, I think it's normally denoted as an error. While dealing with trapezoid and what's that? Yeah, those.
Yeah.
And Simpson, yes.
You probably got my link, right?
Yeah, I did. Thank you. We can move to C, right?
I'm so happy, like I'm making progress. Okay, fine. Write down down the system's equation that need to be solved in order to construct a natural cubic spline of equation of the following data.
Okay. This one I'm completely clueless.
We have to know, this is probably one you have to know the formula for.
Okay.
Yeah. Oh my gosh, I have tons of studying to do. This is not normal. Here, we have this whole page.
Oh, can you zoom in?
Memorize this, I guess. But memorize everything. It's just... So it's a cubic A plus cubic B plus squared plus C plus nothing plus D plus constant. Oh, should I keep on paging? Now when you know this, what is A? A is SR plus 1 minus SR.
Okay. Where will we need that?
The question asks, write down the formula you need.
Or write down the system of equations. Okay.
Because this has to be memorized.
Can you draft a solution to this and then you send it?
What do you mean?
We have this table, right, with our x and our function.
Yeah.
So is it a 32 or 3.0? What is this?
Okay. Write down the system of equations needed to solve the
Your voice is slowly fading.
Oh, sorry, I moved the mic. Okay, fine.
Okay.
It's probably is 3.0.
Okay.
Where are you getting SYR from?
SI plus 1 minus SI. I'm seriously clueless on this one.
Well, SI equals the is GIXR. I'm so clueless. Yeah, me too. Let's see if they've ever asked. This is the kind of questions I like them asking. These easy peasy ones.
Yeah.
Let me go see if they've asked this question before.
Yeah, this was the first time actually I see it being asked.
Okay, should we divide and conquer going through the memos?
Yeah, well, because I usually work with the memos.
Yeah.
To guide me towards the answer.
By the way,
and
this
then,
is what I was talking about. One thing I read for you before was this.
Oh, okay.
That was in which one? 103 of 2012.
Okay.
This is the same question in 2011. They asked the same question.
2011 is, do we have a memo to it? You see, so what I've realized is they pick up questions from the previous years.
Yeah.
But thing is, we don't have the memos for all of this.
That's why they don't give them, because they're able to reuse them without wearing something someone's going to. You know what I mean?
Yeah.
Okay, fine. I think I know what you're going to do. I think it'll be like this. Problem is, I don't have any way to show you what I'm doing, because I'm doing it all by hand. Well, I guess I'm going to hold. Let me turn on my video. I didn't realize it was off. If I do it on this paper.
So you don't have. You can't send it. Thing is, you can solve it, and then send it after. It will be fine.
But basically, I'm asking you, if I hold my thing towards the camera, can you see me now?
I can see you, but what I...
Like if I go like this, could you be able to see what I'm doing?
That will be very, very hard.
Okay.
Yeah.
You wouldn't be able to read this. Sorry, it's blank. Like this. If I go like this, would you be able to see what I'm doing?
Yeah. Yes, but I would.
Is it backwards?
No, it's fine.
Because I'll just... Basically, what I'm going to try to do is for each row, I'm going to do S0X, and I do the X of that row.
Okay.
1 minus, like minus 1, minus 1, minus 1, or whatever that row is. And where would the Y go? It'll be for X equals this. For X equals, for the second row, I do this.
Are we finding the equation?
What?
Are we finding the equation in C?
Yeah, in C we have to make an equation for it.
Okay. Let me find if
This is too much to memorize, though. Okay. So I'm going to do it.
Okay.
Problem is they tell me I don't need to solve it, so why am I... I'll take forever for this question. I don't think it's worth it. How much marks is it for? 8?
You reckon?
Right, it's for 8 marks, correct?
Yes, it's for 8 marks.
What's the step size? They give us a step size?
What's that?
The H.
Is it not a 0.1?
I guess so. I mean, they don't tell us outright, but I guess it is 0.1. X minus 3.0 cubed plus over 2 times. I don't think they can answer this question. It's not fair. You know what I'm saying? It's like, it'll take too long. Squared plus minus 3. I think we'd have to do it like separately. So C1 would be like, even just the 6 throws us off.
Huh?
Oh, the SI is a derivative at X.
Okay.
Basically, I'm going to show you my working out now. Okay. Basically, okay, we have X1, S1. I did the A. I worked out what A was. Like I just wrote the formula. X minus what X is now, cubed, plus what B is. B is S1 over 2.
Okay.
Times X minus X1, X minus 3.3.0. Did it wrong there. Plus C is very long. C is the Y value the next time minus the current Y value. But because they both are minus, they become plus. Over the step size, 0.1 minus the step size, 0.1, 2.1, and the S1, I can't really see myself, plus the step size and S0 over 2 times X minus 3, and then plus D, which is just Y.
Okay.
It's backwards. And then you have to do it 3 times for each sum.
Wow.
And what is S1 though? S1 is derivative of the function G at X. But we aren't given the function G.
Okay. Wow.
That's just weird. I don't know. I think I'm doing it wrong. So I guess we'll come back to that.
Okay, consider the function that.
By the way, using 4 decimal arithmetic, if you're using your calculator, you have to make sure it's set in radius, in gradients or something like that.
Yes.
You make sure it's in the right function.
Yeah.
So it's not rounding it off for you. How'd you set it up again? I forgot.
Which calculator are you using?
I think I did it in radiant. This one.
Oh, nice.
What?
Yes, that's the same one I'm using. Just go to, how do you do this? Okay, you go shift and then set up.
we're fixing it to 4, maybe. Yeah, I fix it to 4.
Oh, you fix it to 4.
I went at this shift setup, 4
Yes.
making it radius, and then shift setup fix, and I put it 6 at 4 decimal places.
Okay. Okay. Yeah. So you went shift and setup, and then you hit your 6 for fix.
Mm-hmm.
And then you chose 4, right?
Yeah, because that wasn't needed for the sum.
Okay.
Okay, fine. Have fun. See, instead of doing 8 in the exam, I would do straight to 7. Straight to D. Instead of doing C with 8 marks, I would do D for 7 marks, which is much quicker.
Okay, how do you do it?
7, in order to be a cubic spline, first of all, it has to be continuous. Well, it's continuous because you see that it includes 2 over here and it starts from 2 over here, so it's continuous.
Okay.
And you have to see if f of 2 at this sum is the same at f of 2 of this sum.
Okay.
The derivative of the f of 2 at this sum is the derivative of this sum.
Okay.
So I guess we can do it now.
Yes. So the first
I think we have to stop at like midnight because we have to do. But I'm very happy that I've made such progress. I'm very happy to study with you tomorrow night if you want.
Yes, I'm on. You know, I'm.
And totally make your own Zoom room and post it on the group. It shouldn't be limited just to me.
Okay.
You know what I'm saying? I'm sure other people aren't working on Sunday. I just happen to be working tomorrow.
Oh,
I didn't want to take the day off because.
But you know, people aren't really helping in the group. You know.
I know people are just selfish.
Yeah. So.
They just come there for the answer. But it's true, it does take time to help other people. But I was working on Friday with someone else on the group. Someone else joined my Zoom room with the teacher. So maybe she'll work with you tomorrow. You just post in the group and see who joins. You can just turn on Zoom. I don't know what your data situation is, but you can always just turn on Zoom and then when someone joins, you can just speak to them. You know what I'm saying?
Okay.
For me, it just helps me even just study by myself because if I know that someone could technically be joining any minute, I better start studying. I shouldn't be faffing on my phone.
But I'll make sure I go through most of the stuff you did.
Mm-hmm.
I'll also check the video you guys had yesterday with the lecture.
Yeah.
But she sounds like not a very good person though.
I don't know. She explained to me later on. If you see later on in the video, she explained it to me. I think she's good at computers, but she explained to me later on.
Because
step by step.
Okay. Oh, okay.
Just skip to the. I find the professors aren't so helpful, but I just take what I can get. You know what I'm saying?
Yeah.
Who's your go-to video person?
Thing is, now I don't really have. I'm just working with the memos.
Mm-hmm.
Yeah.
That's a good idea because that's you're gonna definitely pass.
I'm working with the memos, so what I do is just use those as my guidelines.
So
but it gets really tough when you find questions like this that have no memos at all, and then you have to like seek answers now.
So basically, I don't think this is a cubic spline because of this. Do you do it?
No, I didn't do it.
Basically, I took these sums.
You said step one. Step one is
find the derivative
of
each of those lines, which gave me that.
Okay.
And then plug 2 in the derivative and see if they're the same thing. And I got this. They are the same thing. One is 63, another one's -1.
Oh, okay.
But let's try for the third derivative. Maybe it's just my maths is terrible. Let me try.
right. Let me just.
So basically, it's not a cubic span.
Okay. Let's try.
Because you can say g of x1 equals this. G
We
of
substitute.
x2 this. G of 2.
Okay, your third derivatives, right? You have 46 minus 30x for the
Yes.
first one. And then you have minus 44 plus 18x for the second one.
I got 9x. Yeah, it's 18x. Sorry, my mistake. It is 18x. Let me try 18x.
Okay. And then we substitute 2 in each.
Yeah.
So it's 46.
And they don't match, so it can't be a cubic spline.
Okay. Yeah, because I had 14 and minus 14 and minus 8.
So they're not the same, so it can't be a cubic spline. Because you understand?
Yeah. So it's only a cubic spline when they are equal.
When they're equal, because it's basically it's dot to dot. If you have two lines like this, if the gradient at the end of this dot is not the gradient at the end of this dot, you have a problem. It means they're on the same dot.
Okay.
Okay, question 4. I did a very similar question in that video. You can look.
Okay.
We did it together.
Okay, so I should play the video.
Yeah, I'm sorry, the video is very long, but
maybe you can. Yeah, I can just scroll through, right?
Yeah, put on 2 times the speed. Okay. What the degree of the approximating polynomial on which 1/3 is based? Was 3rd or 4th degree? This is a SWOT question. I guess the good thing is just know the SWOT question, because then you could just do well on them.
Okay.
They've asked it for.
So you think this one might come out?
It's come up a few times. Okay. It's on the quadratic. It's a 4th degree.
Okay.
And if they ask about the 3/8, that's on the cubics in the 3rd degree.
Mm-hmm. Okay, wow.
Okay. Find the approximation of the integral 6 to 0 based on the means of the composite 1/3 rule for 3 subintervals.
Okay, which one are we doing? A?
We did A, after you watched the video.
Okay.
B, we told you it's a 4 degree.
Okay.
C, we can do now together.
All right.
Can I post the video of this on the group?
Yes, you can.
Okay. Just have to get permission from everyone, because otherwise it's not so nice.
Yeah. So the composite Simpson. How do we go about that one?
So I'm using the summary notes to do this because I haven't memorized it yet. Probably should, because they always ask a question on this.
Yes.
They also always ask on multiple integrals or improper integrals, something like that. Like I feel like we need to practice this section. Well, how I memorize it is. It's so weird. I think there's something wrong with this summary paper.
Okay.
I don't understand this. We're doing the 1/3 or the 3/8 1/3 rules.
It's 1/3.
Yeah, that's how I remember it. 4/2. Basically, this is how I memorize it. On the first expression, I think the F0 and the Fn is always times by itself. There's nothing times by. And the middle, it's always 4/2, 4/2, 4/2.
Okay.
With 4 always being on the outside and 2 in the middle.
I'm confused now.
The way I memorized this equation.
Yes.
Yeah, is that on either side we have times 1, times 1.
Okay.
In the middle we have 4, 2, 4, 2 until right before it's going to be a 4.
Okay.
Like if there was a gradient of, if it was a matrix, it would look like this. It would look 1, 4, 2,
2, 4.
4, 2,
Okay. 2.
4, and then eventually it's going to go back to 1.
Okay.
4, 1.
All right, I see.
That's how I memorized that one. It's but first it's h/3. Okay, so let's do this question.
Okay. So we can just do this question now, right?
Yeah.
So it's for 3 sub-intervals. It's
What? Okay, fine. I've got a bit of a problem.
Uh-huh.
Usually we can't do it and if the panels are odd. We have to do a sub-interval of one or the other, whichever one is more linear, with the trapezoidal rule, and the rest with the simple rule, with the Simpson's rule.
Okay.
So what does this mean?
I really don't. Things I haven't tackled the question like this.
Because usually, if it was 2 sub-intervals or 4 sub, it would be no problem, because you can do symptoms 1/3 row without any intervals, plain, simple, straight from them. But if you have 3 sub-intervals, apparently you do half with the, let me Google this, half with Simpsons and the other half with, let me try Simpson 1/3 rule with 3. What would I do without internet? I don't know how people did this degree 10 years ago, 20 years ago.
I know, eh?
It's hard enough today. I could not imagine doing it without computer. It's going to tell us the answer. Not very nice. What are you doing this degree for? This module for?
Oh, actually, why I'm doing this is I'm not a full-time scholar with UNISA.
Yeah.
I just do it to get my credits back in the University of Johannesburg.
Mm-hmm.
Yes.
They don't offer this course?
Yeah, well, I just need to get credits for some module. Yeah.
Oh, wow. So I'm doing the full UNISA.
Shucks.
It's really awful.
And how is it going so far?
It's awful. It's just bad. I'm abroad a lot, so I have to do distance.
I'm sure it sucks.
It's really bad. But some other universities have like video, like weekly lessons with webinars, like this with teachers.
Yeah, I don't know why they don't offer this.
It's so silly because we can really be easier if we had a weekly class with teachers online.
So with 3 sub-intervals, would go fx plus 4, and then you go back to 1. Or how would it be?
I don't know what it'd be if it's n equals 3. Because it's saying you can't do it if n equals 3. You have to do something else.
Okay.
Right? That's what I got. With this is crazy. You understand what they're saying?
Right here, a simple solution is to apply Simpson's standard rule to the first n minus 3 grid points where n minus 3 is even for n odd, and cover the remaining 3 grid points via. I don't understand.
Yeah, soon. Oh, it's midnight. Okay, fine. I think I need to go.
Okay.
Yeah, thank you so much for letting me use your room.
Okay.
So, I guess we can just give up on this. Yeah,
I'll just try
this.
Okay.
What's a function?
It's x plus 1 all to power 3. Yeah.
X plus 1 cubed, correct?
Yes. X plus 1 all cubed.
Let me use Google because currently I'm just using Bing and it's not working. What's it? No. Simpsons 1/3.
Oh. Go to your edge and then just copy the URL and then paste it here.
Yeah.
Okay. Where was the calculator? Was it in your edge?
Where?
Your edge? Where you were doing the calculations before you jumped into
Google.
Chrome?
Oh,
Yes.
I don't. Let me get that.
Yes. Just take the URL, yes, and then paste it. Yes.
One plus x
All
cubed.
cubed. Yes.
It's 1 and 6.
Yeah.
H equals 3.
3, yes. It should show steps. Yeah.
Yeah, it says it must be even. I think we follow this, which is for all 3, but 3 consecutive, and use the 3 minus 8 for what's left over. So n equals 1 with n even, so there's an odd number of.
What the hell is going on here?
There's a video on it, maybe that will help us. Should we just watch this video?
Yes, we can.
Sorry, I just speed and then.
Okay.
Slow down a bit.
You can. Thing is, are we on the odd?
I don't know. You do like something about like half of it being symptoms rule and other half 1/3 rule, other half being 3/8 rule.
Okay. Wow.
Okay, I don't know what to do with this one. Well, my suggestion is just to take a picture and send to the professor. So use your response to like very specific questions.
Okay.
Like take a picture of all the questions we don't know how to do and say, sorry, can you help us? And she told me maybe she'll check it on Sunday. Maybe she'll check an email at home.
Okay. Right.
But
So
you gotta.
it's. Sorry.
I don't know, we probably should watch a video on this in general. I'm just exhausted. I need to go to sleep. So I guess that's that.
Yeah.
Just
But
the
I'll
questions.
just try to go through whatever I can now.
And see if you can find questions for those, answers for those.
Yeah. Yes.
Right, perfect. Barnes, have a good night.
Right. Have a good